Hey, what's going on guys? Tanmay here for Simple Snippets and welcome back to another video tutorial on data structures and algorithms. And today in this tutorial, as the title of the video suggests, we're going to take a detailed look at post-order tree traversal DFS technique. Now before proceeding, if you've missed any of the previous tutorials in this course, in this DSA playlist, we've been talking about trees, binary search tree, and we also started off with the tree traversal as well as the implementation of binary search tree. When I say implementation, it means the writing of a C++ program to implement the binary search tree. And in the previous few tutorials, we've discussed what is tree traversal, the different types. We've also seen the in-order as well as the pre-order techniques. So in case if you've missed any of the videos, in case if you have any doubts of what is a binary tree, what is a binary search tree, what is tree traversal, and the different types, please make sure you watch the previous tutorials of this playlist. I'll drop the link of this entire playlist in the video description. You can probably see a card, and if you have already seen all those, you're good to go. In this tutorial, as I mentioned, we will take a detailed look at post-order tree traversal technique, which is a DFS technique. We will go through the pseudocode, as well as at the end of this tutorial we will write a C++ program to implement the post-order tree traversal on this example that you have over here. This is a BST tree, that is a binary search tree. So make sure you watch this video till the end, and with that being said, let's get started. If you're new to my channel, my name is Tanmay Sakpal and I do a lot of computer science and information technology video tutorials like computer programming, development, technology talks, and a lot more on this channel. So if that's something you're interested into, then definitely subscribe and turn on the notifications to get the latest updates and never miss out on such important topics. Okay, so as you can see over here on the top left, we have the three main steps to perform the post-order traversal. We've discussed this theoretical algorithmic steps previously when we saw the difference between the in-order, pre-order and post-order techniques. But now in this tutorial over here on the left hand side at the bottom, this is where we have the pseudocode. Now pseudocode is nothing but part English, part code kind of syntax, which is much more easier to convert into a proper code, okay? So just by reading these English algorithmic steps, you cannot really write a program very clearly, but the pseudocode helps us achieve that. So converting these three steps into the pseudocode, what we are doing is we are going to follow a pattern of left, right and then node. So what do I mean by left, right, node or LRN? So step number 1 in the theoretical part says traverse the left subtree recursively by calling the postorder function. Step 2 says traverse the right subtree recursively by calling postorder function. And step 3 says access the data part of the current node. Okay. So this word recursively is important because we are going to use recursion in our code. I'm assuming you guys already know what is recursion and recursive function. If not, I have a dedicated video on recursive function in C++, so that will be very helpful. I'll drop the link in the video description, or you can see a card on the top right corner. Please make sure you watch that. As a beginner, a lot of times we get confused with recursive functions and what is the concept of recursion. I have explained it in detail in that video. But coming back over here, our goal today is to traverse this entire binary search tree. So this is a binary search tree, BST. A binary search tree is nothing but a binary tree which follows the principle where every node has its left subtree who has less values and has a right subtree who has larger values. So for this particular node N1, the value is 30. So everything in the right subtree, so this is the right subtree, all the values in the right subtree are lesser than 30. Correct? 18, 10 and 25 are lesser than 30. And all the values in the right subtree, so this is the left subtree and this is the right subtree, all the values in the right subtree, which is 45 and 65, are greater than 30. So for this particular node, this is the left subtree and this is the right subtree. So for N2, 18 you can see is greater than 10, that is 10 is smaller than 18, hence it is a left subtree or left child. N5 has the value of 25, which is greater than 18, hence it is to the right of 18 or right of N2. Okay, I'm guessing you guys already know all these concepts. We've discussed them in detail, so I'm not gonna waste a lot of time over here. But ultimately binary tree and binary search tree both have the same structure, and this binary search tree has this extra principle. So our goal is to traverse from this root node N1, this is the root node, and traverse this entire tree and print all the values. Okay, so that's our function today. That's why I've named as print post order. Basically, we are going to access every node. So that's the goal. And these are the three steps. Now converting them into a pseudocode, of course, when you write a C++ program, you cannot recursively traverse infinitely, right? You have to stop somewhere. So you will start with n1, n2, n3, n4, n5, n6. You'll traverse this entire tree, but you'll have to stop at particular point. So that is why we have this step number 1, first step, which is the stopping condition in the recursion. And the condition is if r equals to null, then return. So this is our function name, void print postorder. It takes a tree node and the star represents the address basically, because we're going to write a C++ program and we're going to play with pointers. So in that case, this is the syntax. In that first step is the stopping condition for the recursion. Now step 2 is print postorder, and we are saying r of left. So when you pass r of left is the left subchild. So that is step 1 in this algorithm. You can see traverse left subtree by recursively calling postorder function. That is what we are doing programmatically over here. So this English step, when you convert into pseudocode, it is basically just calling the function print postorder. This is the same function and passing the left subchild. Then for step 3 is equivalent to step 2 in the algorithm, which is traverse right subtree by recursively calling postorder. We are again calling print postorder, but here we are passing the right subtree. And the fourth step is nothing but the third step over here, that is access the data part of the current node. We say print r of value. Okay. So these are nothing but the recursive calls. And of course, I will go step by step to see how the recursion progresses on this diagram to show you the working. That will give you the best understanding, and then we will write the code. Okay, so now let's dry run this pseudocode onto our example. Okay, so when you dry run this example, let's say we are calling the first print postorder function. This is the first print postorder function, and of course you'll pass n1 because n1 is the root node. I hope you know what is this. This is a node. The center element is actually the value. The left element is a pointer to the left child. That's why it is storing address. So hash 16 is nothing but the address of n2. You can see n2 is created in the memory at this address hash 16, and that is what is stored over here. And then we have the right element, which is again a pointer to the right child. So n3 is created at the address of hash 99, and 99 is stored in the right element as a pointer. Okay. So when you call the first print postorder function, you will pass the root node because we will always start the traversing from the root node. So you're passing n1. Okay. Alright. So let's see how this function proceeds. So when you start with the execution for the first time, that is the first print postorder, the first step is if r equals to null, then return. So r this time is going to be n1, right? So r is nothing but n1. So we check if r equals to null, which means we are checking is n1 null? No. n1 is created in the memory of hash 31. It is not obviously not null. So first step will not be executed. When the first step will become true, we will directly return from this step itself. We will not proceed further. But in this first print postorder call, this first statement is false. So we will not execute step 1. That's how if else works. We will proceed to step 2. Now in step 2 we are saying print postorder r of left. So we are giving a recursive call, but this time we are passing r of left node. Now r currently is n1, right? We just said r is currently n1. So r of left is nothing but the left child to r. So n1 has the left of hash 16, which is nothing but the address of n2. You can see it clearly over here. So hash 16 is nothing but the address of n2. So basically we are giving a recursive call, and this time we are passing n2 over here. So a second print postorder function will be called, and inside that we will pass n2. So you can see a second print postorder is called from the first print postorder, right? So this is why it is a recursive call. When we say recursive call, it means that the function called itself. And when that happens, the first print postorder function will go into a pause state. Because if you see, for the first print postorder, we were at step 2. And at step 2 itself, we called one more function. Which means that for the first print postorder function, we still have step 3 and step 4 left. But before we proceed to step 3 and step 4, for the first print postorder, we will first have to execute this second print postorder, because that is called at step 2 itself. So now, our first print postorder will go into a pause state, and it will go into a pause state at step number 2. So I'll write a pause symbol over here, and I'll write the step at which it is paused. because obviously for a function to complete its execution, all the steps inside that function has to be executed. But for first print post order function, we only executed step 1 and step 2, and at step 2 itself we called one more print post order, so that will execute now, and the first print post order will go in a pause state. So that's how recursive functions work. Okay, alright. So for second print post order, as I mentioned, we say r of left, and the left of n1 is nothing but n2, so that is going to be passed. So now let's execute print post order again, and let's resolve this second print post order call. Okay, so for second print post order function call, we are passing n2, so r is nothing but n2. Again, the first step will not be executed because we are checking is r equal to null. R is not null, r is having the address of n2, so this is not executed. We will proceed further. Now again a print post order function call is given, and we are saying r of left. Currently r is nothing but n2. Who's there to the left of n2? That is the left child of n2. It is n4 because hash 6 is the address stored over here. So now again a third print post order recursive call is given. So a recursive call is given from second print post order, and this time we are passing n4. Okay, and again this is at step 2, which means this second print post order function will get paused. So I'll do a pause sign, and it also got paused at step 2. So let's write 2. And now we will start with the execution of third print post order with the node of n4. So now r is going to be n4. So r is this and not this when you're executing this function. We will again start with step 1. We will say if r equals to null, no, r is not null, r is pointing to n4. So it has some address, it does not have null. Then we proceed to step 2. Now we say again a recursive call at step 2. We say print post order and we say r of left. Now r is currently pointing to n4, and if you observe, we don't have any left value, we don't have any right value, which means that programmatically it will have null. Correct? Just assume that it will have null, because in the program when we write, when there is no left and right child, the value that is stored is always going to be null in this pointers. So now we will call one more print post order. So a fourth print post order function is called from third print post order, but this time the value that you're passing, you can see for the node is null. So here you're passing null, and again when the fourth print post order is called at step 2, this third print post order will go in a pause state at step 2 itself. So let me write a pause symbol over here, and now we will start with the execution of fourth print post order. So I hope you're getting how the entire recursion is progressing. Let's proceed forward and let's start the execution of fourth print post order function call, where the r value is null. So now this time r is nothing but null, and when you start with the execution of this fourth print post order function, the very first statement we check if r equals to null, and this time r is obviously null. We just mentioned and we just passed null in it. So now this if block will be executed, and we say then return. Now when you say then return, programmatically what will happen is this function will stop its execution at step 1 itself, and it will complete its execution. It will not proceed with step 2, 3 and 4. It will directly come back from this first step itself, which means it will complete its execution and it will return back to the calling function. Who called fourth print post order? It was called from third print post order, right? So that is where it is going to go back. So from fourth print post order, it will go back to the calling function, which is third print post order. So that's how recursion works. I'm guessing you guys already have figured it out. If you watched the previous 2 tutorials, the recursion progression is pretty much exactly similar, just that the order in which the value is printed or accessed is different. Okay, so this is for those who have already watched the previous tutorials, but for those who haven't, this is how recursion progresses. And when we come back from fourth print post order back to third print post order, you can see that this third print post order function was paused at step number 2. So third print post order got paused over here. So now it will again resume its functioning back from step 3, because step 2 is done for third print post order. So for third print post order, we will start from third step, and then here we will again call print post order, but this time we are going to say r of right. Now this time in the third print post order, you can see the r value is nothing but n4. So r is nothing but n4. So at third step, when you say print post order r of right, we are saying n4 of right. Now for the node n4, do we have anything to the right? We have nothing, so we have null. So again we will pass null. So a fifth print post order function is called with the value of null. So you can see a fifth print post order is called from third print post order and we are passing null. So when the fifth print post order will be called at step 3, this third print post order again will go in a pause state. So it will go in a pause state at step 3. So let's write a pause symbol. And now the fifth print post order will start its execution. Now for fifth print post order we are passing null. When we pass null, the R becomes null over here, and at the very first step we say R, if R equals to null, then return. So obviously we will not progress with 2, 3 and 4. We will come back from the fifth print post order function back to the calling function, which is third print post order, because third print post order gave a fifth print post order function call, right? Okay, so now that we come back again, this third print post order was paused at step 3. So it will again resume its operation from step 4 because third step is done. So when it resumes, we only have one step, which is fourth step left, and which states that we have to print R of value. Now when you are in the third print post order, the node value that is passed is n4. So R is nothing but n4. Now when you say print R of value, you are saying n4 of value. What is there as the value of n4? It is 10. So this is nothing but value, also known as data, also known as key. Right now we are calling it as value. So that is going to be printed because fourth instruction is to print the value. So I'm going to write the output over here as 10. Okay. So our very first node value is printed. Okay. So after step 4, the third print post order will complete its execution because we only have 4 instructions, 4 statements. So now it can go back to its calling function because of course third print post order function was called by second print post order, right? So once it is done with its execution, it will obviously return back. So from third print post order, we come back to second print post order. So when you do that, when you come back to second print post order, this second print post order will resume its operation. It was paused at step 2. You can see we have a pause symbol at step 2. So it will resume from step 3. So what is there at step 3? At step 3, we are calling print post order and we are saying R of write. So at this function level, at this second print post order, the R value that you're passing is n2. So R is nothing but n2 over here. So when the step 3 is executed, we are saying print post order R of write, which is n2 of write. So n2 has a write of hash 26, which is nothing but the address of n5. So basically we are passing n5 over here as the argument. So a sixth print post order function is called from second print post order. So this is the function call over here, and we are passing n5 as the argument. And when you do that, of course, the second print post order will again go in a pause state. So let me write the pause symbol, and it is paused at step 3. So let's write step 3 over here. And now let's get back to execution of sixth print post order. So when the sixth print post order is called, we are passing n5. So R is nothing but n5 in this case. We check if R equals to null. R is not null. R is n5. Then we proceed to step 2. At step 2, we are giving a recursive call. We are saying print post order R of left. For n5, do we have anything to the left or right? In both the cases, we have null. So seventh print post order will be called. But we will pass null in it. And sixth print post order will be paused at step 2. Okay. So when the seventh print post order will be called and when you pass null in it, of course at the very first step we will say R equals to null, then return. So seventh print post order will do nothing but just come back again. So from seventh print post order it will come back to sixth print post order because sixth print post order called seventh print post order. So now sixth print post order will resume its operation from step 3. What do we have at step 3? At step 3 we have one more recursive call, but this time we are saying R of write. So for sixth print post order with the value of n5, do we have anything to the right of n5 as a right child? No. So again we will pass null at step 3. So eighth print post order will be called. And the value passed will be null. And of course the sixth print post order will be paused at step 3. So when you execute 8th print post order, when you pass null in it, of course at the very first step, we'll check r equals to null and then we'll return back. So we will come back to the calling function, which is nothing but the 6th print post order. So now 6th print post order will again resume its operation from step 4. At step 4 we have nothing but print r of value. Now r over here is nothing but n5 in the 6th print post order call, right? So n5's value is nothing but 25, and at step 4 we are printing that value of 25. And once you do that, you have done with this 6th print post order function, because all 4 steps inside the 6th print post order is done. So after printing, you can go back to the calling function. Who called the 6th print post order? You can follow this arrow and you can see the 2nd print post order gave a call to 6th print post order. So you'll now go back again. When you go back, the 2nd print post order will resume its operation. It was paused at step 3. Step 3 is done. So it will resume from step 4. So step 4 for this 2nd print post order, which says print r of value. So when you are at 2nd print post order level, the r value is nothing but n2. Okay. So when you say print r of value, you're saying n2's value, and n2's value is nothing but 18. So I'll write 18 over here. And once I do the step 4 for 2nd print post order, it will also complete its execution. So it can go back to its calling function. Who called 2nd print post order? You can see the blue arrow. It is called by the 1st print post order. So you'll go back. Now when you go back over here, the 1st print post order, which was paused at step 2, will resume its operation from step 3. So step 3 for 1st print post order is nothing but again a recursive call which says r of write. For 1st print post order, r is nothing but n1. What is there to the right of n1? We have hash 99, which is the address of n3. So now we are going to pass n3 over here. So a 9th print post order is called from the 1st print post order. You can see over here. And once that call is given, the 1st print post order will be paused at step 3. So let's write 3 over here and do a pause symbol. And now we can go with the execution of 9th print post order with the r value or with the node of n3. So executing the 9th print post order, the value or the node is passed as n3. So r is nothing but n3 over here. So first step, if r equals to null, no, r is not null, r is n3. Then we move to step 2. In step 2, we are saying print post order r of left. Now r is n3. Do we have anything to the left of n3? No, it is null. So we're gonna do a recursive call, that is the 10th function call from 9th print order, you can see, and we're gonna pass null as the node value. Okay. So when you call this 10th print post order, of course the 9th print post order will go in a pause state, and it will go in the pause state at step 2. So let's write 2 over here, and it is paused. And now we can execute the 10th print post order. So when this 10th print post order starts its execution, and when you're passing null in it, of course at the very first step itself, we are checking r equals to null and we are saying return. So it will do nothing but come back again to the calling function, which is the 9th function call. Correct? Okay. So when you come back from 10th print post order back to 9th print post order, the 9th print post order will resume its execution from step 3 because it was paused at step 2. Step 2 is done. So for 9th print post order, the step 3 is nothing but one more print post order recursive call, but this time we are saying r of write. For 9th print post order, r is nothing but n3. What is there to the right of n3? We have hash 83, which is the address of n6. So now we are going to pass n6. So 11th print post order function is called from 9th print post order, and we are passing the right child, which is n6. So the 9th print post order will again get paused at step 3. So let's do the pause symbol at step 3. And now we can begin with the execution of 11th print post order where we've passed n6. So for 11th print post order with the node value of n6, r is nothing but going to be n6. First step, we check if r equals to null. No, r is not null because r is n6. So we go to step 2. In step 2, we say print post order r of left. What is there to the left of n6? It is null. So a 12th print post order is called from 11th print post order. So 11th print post order goes in a pause state at step 2. But since we've passed null in the 12th print post order, it will do nothing but return at the very first step itself. So it will come back again, correct? Now 11th print post order will resume its operation from step 3. At step 3 itself we have one more print post order call, and we are saying r of right. R is nothing but n6 at 11th print post order. For the right, again we have nothing but null, so we'll pass null. So a 13th print post order will be called, and the value that is passed is null. So 13th print post order is called from 11th print post order, and of course 11th print post order will again be paused at step 3, correct? When the 13th print post order is called with the value of null, at the very first step it will do nothing but return. So it will come back again to 11th print post order, and once this comes back to 11th print post order, the 11th print post order will resume its operation from step 4. So step 4 for 11th print post order with the node values n6 is nothing but print r of value. R is nothing but n6. What is the value of n6? It is 65. So 65 gets printed, and step 4 is done, which means all steps for 11th print post order is done, so it can go back to its calling function. Who called 11th print post order? The 9th print post order had called 11th print post order, so it will go back. Once 11th print post order goes back or returns back to 9th print post order, the 9th print post order can resume its operation from step 4 because it got paused at step 3. Step 4 for 9th print post order is nothing but again the printing. We say print r of value. R in the case of 9th print post order is nothing but n3. So n3's value is 45, so 45 gets printed. And after step 4 is done, of course all the steps for the 9th print post order is also done, so even that function will return to its calling function. Who called 9th print post order? It was called by the first print post order. So now we will go back to the first print post order, and when we return to the first print post order, it will resume its operation from step 4 because you can see it is paused at step 3. For first print post order with the r value of n1, when it resumes with step 4, we are simply saying print r of value. R is nothing but n1. What is there as the value of n1? It is 30. So we'll print 30, and after this step, the fourth step, the first print post order will also complete its execution. So it will go back in the main function where it was first called. And this, my friends, is the complete recursive function calls with diagram and with proper arrow representations for the post order traversal of a binary tree or a binary search tree. Okay, so we've successfully dry run this entire pseudocode, and we have also got our output. So all the nodes were accessed in this particular order, in this post order. If you have seen the previous 2 tutorials wherein we discussed the pre-order and in-order, you can compare the outputs because we were using the same binary search tree and the outputs are going to be different. And now that you've seen the entire pseudocode and we've dry run this pseudocode for post order traversal, let's go to the dev C++ IDE and convert this 4-step pseudocode into C++ code and do the implementation. Okay, so as you can see on the screen, I have opened up my dev C++ IDE and we've pretty much typed in quite a lot of code. That is because we've already started with the implementation of binary search tree and we are going one function at a time. So if you followed this entire course, even you would have this entire code. This is where the tree node class is made. We created our own tree node class with the value left and right elements. Then we have also the binary search tree class, inside which we did the insertion. We created the basic constructor as well as the isEmpty function. We also did the print 2D function, and this I will explain to you later on because this is just printing the entire binary tree in a 2D way onto a command prompt so that visually it looks proper. Then in the previous 2 tutorials, we did the print pre-order as well as the in-order. So these are the 2 functions for that. And below this, we will do the printing of post order. So just like print pre-order and just like print in-order, we have print post order. So this is the code, and the only difference is the order in which the 4 steps are placed. Okay, so if you observe this print post order, if you observe print in order and print pre-order, we have 4 similar steps. The first step is common, which is if r equals to null, then return, because the stopping condition is the same. And after that stopping condition, the next 3 steps, the order is changed. Okay, so for pre-order, we are printing the value first, then we are doing the recursion. In order, we are first doing the recursion on left, then printing the value, and then doing the recursion on right. For post order, we will do recursion on left, recursion on right, and then lastly we will print the value. So that's the only difference. I have copy pasted this code. You can pause the screen and type it out yourself. As a beginner, I highly recommend that you type it once at least. I will obviously be sharing this entire code with you guys on our official website. So I'll drop the link in the video description for this entire code. If this code is not yet available, that is because probably we've not covered all the different functions in the binary search tree implementation. But it will soon be available, and in the meantime you can just type it out yourself for better practice. Now if you scroll down in the main function, we've created a menu driven program, and each option 1, 2, 3, 4, 5, 6 corresponds to one particular binary operation. So first operation is nothing but the insertion operation, which we've already typed the code for and we've already implemented. The second one is searching a particular node. We will do that later on. Then we have deletion of node, that is also pending. You'll see that in further tutorials in this playlist. And the fourth one is where we are doing the printing and traversal. So if you scroll in the switch case to option 4, I'm not explaining to you all the code because we've already typed this code in previous tutorials. We'll directly go to the case. So this is where we are doing the printing. So let me just copy and paste saying print, and I'll type pre-order. So first call we are saying print 2D. Okay, so this will print a 2D tree, and this function we will discuss later. You'll find the explanation in a separate tutorial in this course later on. Then we are saying print pre-order, so we are calling pre-order. After this we are calling print in order. So these two things we did in the previous two tutorials, and I'm just gonna copy paste these two lines of code, hit enter. After the endl I'm gonna paste this, and over here I'm gonna say post order. Okay, this is in order. And now I simply have to change the function call. I have to say obj.print post order, and of course you'll have to pass the root node because you'll start the traversal from the root node. Now we of course discussed this object and how we are creating the object. We're using dynamic memory allocation, and everything about this code we've already discussed. So we're not gonna get into the details. We're simply gonna run this program, and we're gonna compare pre-order, in order, and post order outputs and see how they are different. So I'm gonna save this, go to execute, compile and run. Hopefully this should run in the first go. Alright, things are working fine. So we are getting a menu driven program where the program is asking us which operation you want to perform. First we will insert all the node values and create our binary search tree. So option number 1 is for insert. Now for insertion we will create the same binary search tree that we just dry run our entire pseudocode on. So let's switch to that. Okay, so on the right hand side you can see our binary search tree. The first root node value is 30, so I'm going to enter 30, hit enter, and you can see value inserted as the root node. So insertion is working fine. As I mentioned, insertion operation we've already done in previous tutorials. You can check that. Again hit option 1 because again we have to insert more values. We have to insert 18 and 45 next. So when I hit option 1, again I'm being asked enter value of the tree node to insert. So this is 18, hit enter, value inserted to the left. Again option 1 for insert. Now we have to enter 45, hit enter, value inserted to the right. Again option 1, I have to enter 10, so this is that value. Again option 1, enter 25, hit enter. Again option 1, and lastly we have 65, hit enter. Okay, I can clear the screen now, clear the command prompt. Option 5 should do that. So command prompt is cleared, and now we'll do option 4, which will print pre-order, in order, post order, as well as the print 2D, which will print this entire tree in a graphical way. So when I hit option 4 and hit enter, you can see the first printing is this print 2D function which is called, which will print this tree in a rotated manner. So this tree is rotated 90 degrees in the anti-clockwise direction. That is because this is the best way we can represent a tree on a command prompt. So 30 is the root node, then we have 18 and 45 as the left and right child. So over here also in our pseudocode diagram on our digital blackboard we have the same structure. For 18 we have 10 and 25 as its children, and for 45 we only have a right child which is 65. Now below over here you can see we have pre-order, which is 30, 18, 10, 25, 45, 65. Then we have in order, which is 10, 18, 25, 30, 45, 65. And post order, which is what we implemented today in this tutorial, which is 10, 25, 18, 65, 45 and 30. Now if you observe the output, it is exactly matching. You can see 10, 25, 18. We have 10, 25, 18. Then we have 65, 45, 30. We have 65, 45, 30. So this means our post-order pseudocode got converted perfectly fine as a C++ code, and we also got the output, which means we have successfully implemented post-order tree traversal for a binary tree or a binary search tree. Okay, so I hope you've understood this entire tutorial. If you like this video, if you understood the entire recursive behavior, please give this video a like. Definitely let me know in the comments how this video was. Do share it with your friends. Your like, share, comment matters a lot because it takes a lot of effort to create these videos. I'm gonna wrap this video over here. In further videos, we will do more operations on binary trees, especially on binary search tree. We will proceed with the implementation of other functions, other operations. You can check out this entire DSA playlist. You'll find many other tutorials on data structures and algorithms. Many other topics are being covered. Subscribe if you're new on this channel. If you like this video, check out this channel. There are a lot of content for computer science and information technology oriented students. So thanks for watching. See you in the next one. Peace.